Here is the first question that I want us to discuss. So guys, this is our lesson. It's not my lesson. It is your lesson. So I want your inputs, a lot of inputs. So I will be calling your name. So let us look at this one. Which says that a balanced equation of ionization of nitric acid is given by the following reaction. So which one of the following is a conjugate base of nitric acid above? Which one is the conjugate base? Which one is the correct answer?
C.
C. Let us all interrogate C. Is C the correct answer? Is C the conjugate base of nitric acid?
Yeah.
Okay, then if we all agree, then we can say that is the correct answer. Now, let us move to question number 2. Yeah, it's number 1. Which one of the following functional groups is the characteristics of an organic compound formed when an alcohol reacts with an organic acid? Alcohol react with an organic acid. Which type of reaction is that one?
Esterification.
Very good. It's esterification, right?
Mhm.
So then we have to look at the functional group of ester. Which one is is D, ne? D. Now back to question 7. Guys, I said question 7 is not that difficult. The issue is that 7 marks and marks. The first part of this question will never be difficult. Will never. I know this one is a little bit challenging. I understand that one. But the rest of the questions are not. Okay, anyway, let us look at this one and try to get the answers. So the question says that sulfuric acid is a diprotic acid. Ne? Why is sulfuric acid classified as a diprotic acid?
It can donate to protons.
It can donate protons. It's not a reason.
Why? To protons.
Yeah, that one is correct now. It can donate protons. If you check, that question is there. It's a diprotic, can donate how many protons? 2. 2 hydrogen protons. Ne?
Sorry.
Okay. So the concentration of this sulfuric acid is 0.4. The concentration is 0.4. What will be the concentration of hydronium ion? If the concentration of sulfuric acid is 0.4, what will be the concentration of hydroxyam ion?
0.8.
It's 0.8, no?
Yeah.
The concentration of H3O plus is equals to twice concentration of H2SO4. You must always remember, as long as it's a diprotic, né? When acid is diprotic, it will have that character. Né? So if it's a monoprotic, of course, the concentration of the two will be equal. Né? Okay, so this sulfuric acid ionizes completely in water according to the following balance. So why is this called the complete ionization of sulfuric acid? Another question.
Why mean? Okay.
Why is this reaction represent the complete ionization of sulfuric acid?
Ngori. Vananga is Kambori because Vananga is SO4 2 minus or ish.
This question is the same as the question that I asked, né? Or why sulfuric acid is called a diprotic? Is because it produces what? 2 protons, right? So you can see here, we have 2 hydronium ion, right? It produces 2 hydronium ion. The incomplete, can I show you the incomplete? The incomplete, this is the incomplete. This is incomplete ionization of sulfuric acid. Is that clear?
Yeah.
This is incomplete. Now, if you want to have a complete, then you're going to take that HSO4 and you react it with no. I almost do something which is not right. Let me leave it. Let me leave it. Okay, the complete is here. The complete is here, right? It's in the waiting room. Okay. Let us calculate now. Let us calculate. Let us answer the question. I'm just used to calculation. Now, the first question, it says, write down the term for the underline, ionize completely in water. What is that?
Strong.
It represents a strong acid, né? It's a strong acid. All strong acids ionize completely in water. Huh?
Yes, sir.
All strong acids, they ionize completely in water to produce hydronium ions, higher concentration of H3O plus. Now, the issue of Ka in ionization constant, Ka value in the above reaction is high or low.
Many.
Ka value. Which one is the correct answer for 7.1.2?
All right. Yeah. The strong acid AEI.
Ka value of a strong acid
It's high.
is high.
Yeah.
Why? Because it dissociates completely, né?
Water, yeah.
and of a weak acid is low because dissociate incompletely in water. Riakwana.
Yes, sir.
So the correct answer is I. So we've done with 7.1.3. Calculate the pH of sulfuric acid. You see, this one is not difficult, right? But if you don't know that this sulfuric acid is a diprotic, then we're going to have a serious problem. So let us do 7.1 point. We said yes, strong acid, strong acid. Now 7.1.4. pH is negative log concentration of H3O plus. Now, before that, let us calculate the concentration of H3O plus. Is equals to twice concentration of H2SO4. This is 2 times 0.4 and is 0.8. Nah? Back to our pH.
Oh, sir,
Yes.
can I ask a question?
Yes.
You see, when you're calculating the concentration of H3O plus, are you using are we multiplying by 2 because sulfuric acid is diprotic, or are we multiplying by 2 because on the balanced equation the H3O plus is multiplied by 2?
You both statements are correct.
Okay.
But
Okay.
the most correct one is the fact that sulfuric acid is a diprotic. Nah?
Okay.
Di will produce 2 H3O plus. Nah?
Mm-hmm.
Yeah. So mono will produce 1.
So if it was mono, we were still gonna multiply by 2.
No, we can't multiply because if you check HCl nah, plus H2O, this is Cl minus plus H3O plus. That's it. It's 1 here. Nah?
Mm-hmm.
So you multiply by 1, it will not change, right?
Mm-hmm.
1 is that number whereby when you multiply with, it will not change anything. 0, when you add it, it will change. It will not change anything. But when you multiply by 0, something changes. When you add 1, something changes.
Mm-hmm.
Those are 2 special numbers in the number series. No?
Mm-hmm.
Okay, so that is why we multiplied by 2 and to get 0.8, and our concentration is pH. Sorry. What is
0.0 and 0.1.
0.1? 0.1.
Mm-hmm.
Okay. The pH of the solution is 0.1. Now, 0.1 is
Yes, sir.
That can be said.
good.
Later zone, eh?
I was just confirming. No, from Ngari and right. Show. Okay, so let us move to 7.2. Guys, if you check the first 4 questions was not even this one, the one that we're about to calculate, it's not difficult at all. The only challenging question is 7.2.2. Okay, of which we're going to try and see if we can simplify this question. 7.2, Elena adds a sample of calcium carbonate to 50 centimeter cube of excess sulfuric acid of concentration 0.4. Sulfuric acid is in excess, nah? according to the following balanced equation. The first question says, calculate the initial number of moles of sulfuric acid. How can we calculate that? We have the concentration, right?
Mm-hmm.
And what else? We have the volume, right?
Mm-hmm.
So number of moles H2SO4 is CV. What is our C?
0.4.
What is our V? 0.05. So try to multiply the two. You're going to have what?
0.2.
0.2.
No, so 0.02 at least.
0.02 mole. That is the initial number of moles of sulfuric acid. Now, let us come to this second part, and you must listen attentively here, ladies and gents. You must listen, it's a must. It's not by choice. Okay. It says that the excess H2SO4 is now neutralized by this of sodium hydroxide solution according to the following balance equation. So the question says that calculate the mass of calcium carbonate in the sample. Okay. Now we are given the concentration of sodium hydroxide and the volume of sodium hydroxide that reacted with sulfuric acid. That sulfuric acid that reacted, it was in excess. And remember, during neutralization reaction, everything reacts, right? That is why we say the reaction reaches its end point. Everything reacts. Therefore, we can calculate the number of moles in excess of sulfuric acid. That is the first thing that we can do. How can we do that? We calculate the number of moles of NaOH that react using this formula CV 0.5, 0.123, 0.028. Ne? And what is the number of moles?
0.014. 0.014.
0.014 mole. This is the number of moles. This number of, if you check the reaction, it's 1:1. Ne?
Mm-hmm.
Therefore, number of moles of H2SO4
Excess.
in excess is equals to number of moles NaOH, which is 0.014 mole. Then once you get that number of moles in excess, you can now know the number of moles of H2SO4 that reacted Anne? So let us look at this one. It will say that N reacted. Let me do this, and do this, and say NH2SO4 reacted is equals to N initial minus N excess. Ne? This is to say 0.22 minus 0.014 And what is the answer?
0.206.
0.206.
Oh, yeah.
0.206. This is the number of moles that reacted. Then from that number of moles that reacted, we can calculate the number of moles of calcium carbonate that reacted. No? Number of moles CaCO3 of 4, which is 0.206 mole. After that, you can calculate the mass. Number of moles, molar mass. So this is 0.206 multiplied by 100. 1, 2. The answer is 20.6 grams. Then we are done. We are done. Any questions?
No, Mrobjis. Mara ndofadza ndozvibona mara okay, just for clarity. Apana ka information ayori ka was instruction mara mapungo asho palanta yori Elena as a sample of calcium carbonate to 50 cubic centimeters of excess sulfuric acid. Zvino ndotoma ndisongozvijera nta zvori okay, like ndofunga ndiyone reaction hila ine havo uko reactor ya excess yosalaho. Like tongozvijera samusi ichikotori sulfuric acid ine it's in excess. Itedezvo nditori mini mari wako zvipfa.
Okay, yeah.
So ndofa matomoni yayo 721 yacho ichiko like ndotoma ndofandisa kupfesesa zvoro wairi kusvimisa volume ya excess ichiri CV because ndofunga yenewo 50 cubic centimeters ndiyone excess yaone, but like okay ndozviwana.
Okay. All right. So this is how we go about these questions, right? And these days, this is how they do it. They ask these questions in form of 2 reactions. But I think it becomes easy because you know whatsoever that is in excess in this reaction will react here completely. And what they're going to give you is the information of this other substance so that you can relate the number of moles. Sometimes the ratio can be 1:2. You must be careful when you're dealing with the ratio. You must be careful. Okay, now what is going on with all right. Fine, let us look at this one, then refresh in Maluwiti. Yes.
Yeah.
Slide. Okay, let us go back to the slide. Here's the slide.
Apanonika 7.2 tindi 0.4 times 0.05. Then kwana 0.02.
0. What?
0.4 times 0.05.
What do you get?
0.02.
Kazofini 0.02 mara ndokuzisa wenso mamba kare.
Asini wenda vandoamba mara.
Ndikombori ndokuzisa uri ndiyonena. Usavena nera comment hapi ndiyoni. Is it 0.02? Can you verify?
Yeah, it is.
Okay. Then if that is 0.02, then yeah, 0.02. Can you subtract here and give me the answer? I just change with a red.
minus 0.014. You 0.006.
0.006,
Yeah. Which means ratio
then yes,
multiply is going to fall down to 6 grams.
0.006
Mm.
multiplied by 100.
Mm.
The answer is what?
6 grams. Is it 6 grams? I don't know. 0.6 grams. It's on.
0.6. Yeah, just move the comma 2 times. Ne? Yeah, it's 0.6. Now it's okay, ne?
Yeah.
It's okay.
A.
Okay. All right, it was just a matter of calculator, ne?
Mm.
All right, that is how it is done, unless you don't have any other question. If you don't have any other question, we can move to this one and refresh Nyana, because I'm coming with the tough one again. Let us refresh. Question 2 is for control, ne? Always remember that. For question 2 is for control. Once you are done with these tough questions, just go and take any question 2 and refresh Nyana a bit, ne? We use this question to refresh, and I've told you how to answer this question correctly. So you must know all those substances. Today, I'm not going to do that. Today, I just want you guys to give me the answers. Can I have the answer? Let us start with the first definition. Must not take definition for granted. What is a hydrocarbon?
Organic compounds that consist of carbon and hydrogen only.
Carbon and hydrogen only. Compounds that consist of carbon and hydrogen only.
Yeah.
So that is a hydrocarbon. So what is, write down the letters that represent hydrocarbon. Which letter represents hydrocarbon?
H.
Correct letter A.
B. Na A na H.
Very B. A.
Na H.
A is a hydrocarbon.
No, we're not generating oxygen, so it can't.
Butanol.
No, it's not.
Ozifa. Where A? Butanol is not a hydrocarbon, right?
Yeah.
Hydrocarbon only consists of carbon, hydrogen only, nothing else. No oxygen. Okay, so you are saying the correct answer what is B, ne? B.
Na H was.
What about H?
Hey, oh, you didn't you ambao? Unamtu ambao.
E and A, right?
Yeah.
B and H. Okay. Name of the functional group to which H belongs.
H belongs. I'll double bond and double.
H8.
Double bonds between.
Double bonds, right?
C atoms. Yeah.
So what is double bonds? Is the functional group.
Hey, my random name. Hi.
Functional group. Name of the functional group.
It's about to rename, you know. The remain can name. Double bonds between carbon atoms. Hey. What name of the functional group?
That is the functional group, right? Double bonds. We don't have a specific name for alkenes.
For alkenes and alkanes, yeah.
So These are hydrocarbons. Basically, these are hydrocarbons. If they are
Okay.
hydrocarbons, so the one with a single bond is called, the functional group name is called alkane. The one with double bonds, the functional group name is called alkene. With triple bonds, is alkyne.
Okay.
So letter that represent a carboxyl. Which one is the carboxyl? It's for control, remember?
Yangai. Carboxyl igay.
It's G.
Carboxylic acid.
It's G.
G.
Mazithuthal phase yapha awona ama-base yapha vethu.
Etukhovona. Oh, ayovura.
Griffith there. Who else? It's only Griffith. My God, where is Fulu? Griffith is only that team, man. Ufindi if you're G.
Yeah.
G, no? And G can also be an ester, right? IUPAC name of E. IUPAC name Ulu. Informal. The two former this. Botenga. Yeah, there. Botenga. That's only that team, man. Oswald Tenga. Osli. Osili. Okay, what is the correct answer, guys? The name of that one?
1, 2, 3, 4. 4 bromo. 1, 2, 3, 4. 4 bromo.
4 bromo.
Abakungona. Oh, equate. 1,2.
Why bromo?
Asiyona.
I mean E.
Angofi E.
E, yeah. 4 bromo, bromo 4, number 4. This 4, I have a question with this 4.
So can you also
a lower order? Okay,
I'm just asking Uri for from where? From here. Oh, okay, yeah. You are saying from here, which is incorrect. It's incorrect.
1, 2, 3, 4, 5. Okay, tiri khou ṱoḓa ya lower order ine ya ḓovha na low order izwo zwithu. If rather 1, 2 i khou ḓo ri 2 plus 3 plus 4 plus 5. 2 plus 3 plus 4 plus 5. Zwa ri fha vhugai? 2 plus 3 plus 4 plus 5 ndi 14.
2 is 2. Okay.
Hayi abari ndo tshintsha 1, 2, 3, 4, 5, 6
4, ne? Let me use another color. 1, 2, 3, 4, 5. This is the only way where we can get the longest chain, right? It's either with the red or this. What is this pink or purple?
The pink.
Pink one, eh? Okay. Which one is the correct one? Yes, pink.
Okay,
are we taking the pink? Do we have pink? Pink.
Are you
not pinky?
So I think we should take the red one.
The red one? Okay. Red one says what?
2 bromo.
Say 2 bromo, 5
2
4, and then 5, 4, 3 trimethyl pentane.
1, 2, 3
bromo
4.
3.4, ne?
Dimethyl.
dimethyl
Hexane.
hexane.
You?
So what,
Line. Okay, 1, 2, 3.
so what
Let
about
us
the methyl group on carbon number 5?
on carbon number what?
5.
We have 6 carbons, so we cannot have methyl in carbon number 5.
Yakhona.
Remember, we checked the longest chain, eh?
Mm.
The longest chain.
Okay.
Longest assign carbon up to the last carbon, eh?
Mm-hmm.
Assign. Then you will find the longest chain along the way. The longest chain will give you a chain with more carbon. Yeah, if you check here, the longest chain has 6 carbons. It's either we are
Okay.
taking the red or the pink.
Pink.
So the pink is going to be 3.4. That is dimethyl, ne? And we have 5 bromo, so it will give us the highest order, ne?
Which is
And we
wrong.
want, which is wrong. We want the lowest order. Lowest order is this one. The lowest order is this one.
Yes.
Okay.
Yeah.
Mina ndi khou confuse yathi ndi lini hune ra tea u thoma u nambara kha dzi branches like sa hafhanoni ro thoma ngo u nambara u bva hune havha na bromo dzipfhi ra ri bromo i kha number 2 vha u zwi vhona.
You know, the first things we need to as one part do number the carbon. Is this number ro thoma gai? Mara of course ro thoma kha carbon thoma kha left kana kha right. Kha right carbon yo thoma ndi ane as a branch ila.
A thi khou hezwo nda ndo zwi vhona hezwo. Ndi khou uri ndi khou khamusi nṋe vha ose ndo vha pfhisa zwiṅwevho ndi kilasini ndo pfha nga ri vha ose vho ri ri tshi khou neima nthuni heyi ya so ri ḓo thoma nga u nambara u bva kha branch vha khou zwi vhona arali yo thoma kha heyi ye vha vho i ṋanga longest chain zwi amba zwori ro vha ri khou ḓo ri heyi bromo i kha carbon number 5.
1, 2, 3, 4, 5, 6. Okay, yeah. The reason this one is not the correct name, ane? Not the if we have a minor name, we're going to say it's a minor name, but a major name. All right. Why? Because when you add the numbers of the substituent, if you check for this one, we are going to have let me say 5 bromone and 3.4 dimethyl hexane. So if you add these numbers, 5 plus 3 plus 4, what is the answer?
12.
12. Let us add here. 2 plus 3 plus 4. What is the answer?
9.
The one that will give us the least order is the correct name. That is how it is done. That is how it is done. Nothing else. No manga. Yeah.
Network hey.
Which part? Part if you?
Yo wanna pick name.
Wanna mean 90? Okay. How do we name? The question is how do we name? The first thing that you must do is to assign numbers in your carbon chain to identify the longest chain. Riko assigna the number ka carbon ka chain ya uri hafha ngori ko ṱoḓa longest chain uri na carbon ngana And that is why Mandori, we can do it from left 4, 5, 6, or we can do it from right. From right, this is the first carbon. It's just that Rokonita Mululu, writing at the Darari. Okay, let me do this and show you. Instead of having this as H, we're going to have H here and CH3 here. So guys, when we talk of longest chain, we're not saying that they must be on the same straight line. No, it's not like that. All right, it's not like that. So we assign the numbers to identify the longest chain. So far is really. We assign. Okay, after assigning, right? After assigning, now we must name our molecule, right? We must give name to our molecule. So let us check our molecule. We can give name from left to right and from right to left. From right to left, then we're going to choose the pink one. So in carbon number 3, sometimes we take things for granted, whereas some learners, they don't understand. In carbon number 3, we have a methyl. Ne? In carbon number 4, we also have another methyl, meaning that the methyl group will be 3,4 dimethyl. 3,4 dimethyl. There is di here. There is di here. So in carbon number 5, there is bromine. So then our name is going to be 5-bromo 3.4. We follow alphabetical order, you know that. Ne? 5-bromo 3.4 dimethyl hexane. Hexane, the longest chain is hex. It has 6 carbon. Then after doing that, you must check the name which will give you the list number, the list order. So you add those numbers, right? That represent the position of that substituent. The one that will give you the list is the correct one. Riakwana. Guys, this question, I believe each and every one of you must get total. It's a must get total here. That is why I said it's a question for control. Yo, Matunaka name as a control. Okay, let us proceed. So the correct name is 2-bromo 3.4 dimethyl hexane. I hope we all understand that. Ne? Okay, back to our control question. Functional group, define functional. Oh, is compound E primary, secondary, or tertiary? E. Primary, secondary, or tertiary?
Secondary.
Give a reason for your answer.
Because the the carbon bonded to the haloalkane is bonded to 2 other carbon, to 2 other atoms, C atoms.
That is correct, ne? Because the carbon bonded to haloalkane is bonded to 2 more carbons. Ne? If it was bonded to 3 more carbons, it's going to be a tertiary. Ne? Functional group. What is functional isomer? So functional isomer. Same molecular formula,
but different functional group.
But different functional group. Simple as that. You write that, you get 2 marks. Same molecular formula, but different functional groups. Okay, right, for compound A, butanol, write down the homologous series to which it belongs. Butanol is an what?
Aldehyde.
It's an aldehyde. The letter that represents its functional isomer. Its functional isomer. It simply means we must have Bhutan 2-1.
Let's see.
It's letter C, ne? Bhutan 2-1 is letter C. What is the name of the functional group of compound A?
It is ketone.
What is the name of the functional group of compound A?
Is hydroxyl, something like that.
No, compound A. Compound A. If it's compound A, what is the name of the functional group of compound A?
Hydroxyl.
Wrong. Hydroxyl is for alcohol. It's for
Is it a
compound.
carbonyl group?
Yeah, I mean, yeah, A. Formyl.
A.
Yeah, aldehyde.
A is for meal.
Mm.
A is for meal. What about C? For C?
So C again. C.
Yeah.
Okay.
The carbonyl.
Carbonyl.
It's
Ketone. Carbonyl. Yeah.
It's carbonyl. Those are the questions that you can be asked, guys. Okay, anyway, let us move to 2.6. For compound B, B is a branched alkene. Huh? No, it's not branched. CH2 true is butane, that one.
1, 2, 3, 4, yeah.
Is butane. Structural formula of its chain isomer. Which one is that one? It's 2-methyl. 2-methyl what? Propane, eh? This is the structure of its chain isomer. The chain isomer of butane is 2-methyl propane. You must always know that. The IUPAC name of that compound, we said it's what? 2-methyl? Propane. 2-methyl propane. Compound F belongs to esters. F belongs to esters. Stage 2 reaction conditions for preparation of esters. Number 1.
Concentrated sulfuric acid.
Concentrated H2SO4. Number 2.
And H. What's this one? Concentrated.
We also need maldehyde, Batru.
Crystal.
We also need maldehyde. Okay. The IUPAC name of compound F? IUPAC name of compound F. This is methyl. Eh? This is methyl. It's methyl what? Propanoate. Methyl propanoate. So that is 22 marks in the bag. You go home happy. Everyone is happy at home. Now back to acid and base. You know, this one, we're using this question as our control question. Eh? So now we are going back to a question that we want to do. Said we'll also do multiple choice. Okay. Question 7. 1.7. You will find the multiple choice of acid and bases in question 1.7. 1.7. Okay, let us also look at this one. Is interesting. 1.8, very much interesting. Question 2. And question number what? Number 7. Calculate the value of x. This one, x with their x. You know, once they bring x, learners are scared of x because they don't appreciate mathematics. So once you don't appreciate mathematics, then you are scared with x. Yeah, here is our x. So let us start with this one. It says that acid HF ionized according to the following equation. When 0.1 mole of solution of HF is prepared, it is found that concentration of F minus ion is 0.018 mole at 25 degrees Celsius. At 25 degrees Celsius. Now, define strong acid. What is a strong acid? Ladies and gents, how do we define a strong acid?
It ionized.
Sorry.
Huh?
No, you can go on.
It what?
An acid that ionizes completely.
Ionized substance that is acid is a substance that ionizes completely in water to produce a high concentration of H3O plus. Né? That is a strong acid. That is a strong acid. Okay. Is HF a strong acid or a weak acid? Give a
It's a strong.
reason for the answer.
So it's a strong.
It's a strong acid.
Mm-hmm.
Why? What is the reason behind that?
Well, I think that is because it ionizes completely in water. Because at first it was an acid and now it's a base.
Okay. Can I hear from others? What are you saying about this one?
Strong.
It's strong.
Mm.
And the reason?
As an ionizes completely in water.
Ionize completely in water.
To produce a concentration of hydronium ions.
Okay, how do we know that it has ionized completely?
Look at the equation.
By just looking at the equation.
But doesn't it give you a clue when you look at the equation?
looking at the equation, it ionizes completely, né?
Mm-hmm.
But just read the statement, guys. When? Start from when?
When a 0.1 mole per cubic decimeter solution of HF is prepared, it is found that the concentration of F minus ions is 0.018 mole per cubic.
Was it supposed to be 0.018 when the ratio is 1:1 and it ionizes completely?
Ooh, aye. 0. Aye.
You see, this statement here, it was telling us something. It was telling us something about this, right? So not all of HF ionize. How do we know?
Okay.
Because the concentration of F that was produced is not equivalent to this one. It was supposed to be equivalent if the ratio is 1:1. The answer is what?
No.
It's no. Ne?
That's
So,
cool.
well, give a reason.
Concentration, yeah, true.
Ionize
Ionizer.
partially.
You ionize incompletely, yeah. Partially, yeah.
Incompletely. Or we can say that this 0.018 is less than what? 0.1. So they were supposed to be equal.
And then goes gerund.
Yeah.
Yeah.
Okay. Then the next question, calculate the concentration of OH in this solution. Concentration of OH in this solution. So how can you calculate the concentration of OH in this solution? Remember, the concentration of this solution is 0.01. Is 0.01. Okay.
What a minute.
The concentration of this solution is 0.018.
Why? Okay,
why?
Take other HF area H plus F minus. So then
concentration of H3O plus is equals to concentration of F minus, which is equals to 0.018 mole per decimeter cube. Does that make sense?
No, it doesn't.
Why? Because ratio between this and this one is 1:1. I tell you, not all of these are nice, right? Remember, we are preparing this HF. So we found that the concentration now of F is 0.018, meaning that the concentration of H3O plus is also 0.018. Because this HF, it did not ionize completely.
Yeah.
So that is why we are saying, okay, the concentration of H3O plus, it will be 0.018. So when we want to calculate the concentration of this one, we know it's at 25 degrees. We know it very well already. Concentration of H3O plus multiplied by concentration of that one is equal to 1 times 10 to the power negative 14.
So if I somewhere at 25 degrees, can I be with different temperature, then I'm not allowed to apply KW.
We are not allowed. The temperature must be 25. If they don't mention the temperature, assume that is 25. If they mention different temperature, which is not 25, we cannot just assume that this H3O plus multiplied by OH minus is equal to 1 times 10 to the power It's negative 14.
Yeah.
We cannot just assume this. We assume this when temperature is 25 degrees. And if it's not mentioned, we can use it. Alright? Once they mention different temperature, it's a problem that now. Okay, now what is our concentration here? We said is 0.018.
0.18, yeah.
1 times 10 to the power negative 14. And what is our base?
5.56. Yeah, 5.56 times 10 to the exponent negative 13. If not as well.
Negative more per decimeter cube, no?
Okay. Okay. HF okay, HF H ionizer, okay, reaching what equation ya only could HF produces H plus ne plus F minus Ginongori aingo ionizer completely. We are not allowed to find the concentration ya hydronium ions by means of your initial, given that your initial aingo use ya parity.
Yes.
So Rokodosh opta Oshumisa. Yeah. Oh, okay. Yeah, that makes sense. This one.
Because H3O plus is the one that will determine the concentration of that solution. Yeah.
So Naka into the general rate as well.
This is it.
Okay.
If it ionizes completely, then of course you're going to have the concentration equal. Ne? Yeah.
I mean, so to if you mean acidic and a base equal ionizer completely. Acid ndio ni ionizer man. Kama acid equal ionizer completely. Rokosaza zero concentration ya hydronium ions iningana na concentration ya initial ya acid acid should.
Yes, but there are also those acids, yeah. Those acids that we know, this one is a strong acid. It can be a weak acid. Like sulfuric acid, can sulfuric acid be a weak acid?
No, it can't.
No, but this one we are not sure the category of HF. We cannot just shoot and say it's a weak acid, it's a strong acid. There must be an information that will lead us to tell if whether it's a strong or a weak.
So are going to determine the equation.
No.
Okay.
No. It's a monoprotic acid. It will also produce one hydrogen proton.
Oh, it's only as okay, yeah.
Do not. Boom, 7.2. Sodium hydroxide pellets of mass X are added to sufficient distilled water to prepare a solution of 25 cubic centimeter in the flask. 12 centimeter cube of sulfuric acid of concentration is added to the flask containing sodium hydroxide. The total volume of the mixture is found to be 87. Yes, it's 25 plus 12 is 37. And its pH is 12.56. We have the pH of the solution. From that pH, what is that we can calculate?
Amen. Sure.
From that
Keep myself
pH, what is that we can calculate?
Okay, Amen. The total volume of the mixture formed is mini and its pH is 12.56.
Yeah,
Yo.
Chipar, the question that I'm asking is very simple.
And
What is it that we can calculate from the pH? Okay. What do we calculate when we're given pH?
Hydronium, high concentration hydronium.
Of hydronium ion. That is the answer that was expected. Nothing else. I don't want you to ask.
Carbo, okay.
Yeah, what is it you must do with that pH? I can calculate concentration of H3O plus. That is the only thing that I can say I can do with the pH.
Mara. Okay, H3O plus.
Use it wherever I want to use it, but the point is that when you have pH, you can calculate the concentration of H3O plus. That is what I want to emphasize.
Okay.
Okay, this is the reaction. You can see reaction is 1:2. Explain the term dilute acid. What is a dilute acid? A substance that contains small what? Small amount of acid. Over a volume of water. Or in a given volume of water.
Your next exam guideline.
Yeah. Contains small amount acid in proportion to the volume of water, to the given volume of water. Yes.
Okay.
That is the correct definition. It contains small amount. That is a dilute. A strong, it contains large amount. It contains large amount. This is how we differentiate between a strong and a weak acid or base. Okay. Now, how does the concentration of hydronium ions compare to the concentration of hydroxide ions in the mixture? Choose from larger than, smaller than, or equal to. Do you know that the answer to this question is there? Is it higher than? The answer to this question is there. It's given here.
Yes.
How does the concentration of hydronium ions compare to the concentration of hydroxide ions in this mixture? Okay, let me ask you a question. Is this mixture acidic or basic?
It's basic.
It's basic, ne? Then can I have the answer for that?
Oh, I know you.
Can I have the answer to this one?
Basic. What does the concentration of come to the it's less smaller than
the concentration of hydronium ions is smaller than that of H3O plus, ne?
Hydronium and the H3O plus.
The concentration of hydronium is smaller than that of OH
minus. Okay, yeah.
Concentration of H3O plus is less than concentration of OH minus. How do we know that? pH.
Okay.
pH is that pH represents or the solution is basic. And when the solution is basic, it shows us that concentration of H3O plus is smaller than that of OH minus. Guys, Riakwana, I bet this is that question you said you want it, and you want to get to. I'm trying to show you in this question, it's not like it's difficult. It's just that if you don't read statement nicely with sober mind, then you will feel this question is difficult. You cannot crack it. But if you check this question, it's simple. The answer is there. Once the pH is greater than 7, it shows us that the concentration of hydroxide is greater than the concentration of hydronium. When the pH is less than 7, it shows that the concentration of hydronium is greater than the concentration of hydroxide. Guys, that is what you have to know. Once you know that, I think you can get total linear basis. Okay. Calculate the value of X now. X. We want that X. X is not a friend of anyone. But let us calculate him. Hey, before I forget, let us online. Online.
Oh. Hey. Ay. Let's switch at the mangazo.
I don't know. So.
Hey.
51%.
Hey, don't have gay.
51%.
Hey, over 100. Ay.
Over 100. 51% position in the whole country. If it was
position
national state.
What's it?
Of course, I have your certificate here. I will print it out. Now, if no, your position 162.
Never sure.
But let me mention the marks. They will laugh at you, these people, and they don't know that was tough.
No, 30 minutes and listen while they go routine that's not question paper. Mara, like, ever never. Wow.
Okay. Yes.
Nebeni lemtoni ndandikoza kuvumbela ndasakubona question paper ndechipinga chako tuwa ndasakori BC andikoza kunanga.
But when instruction was go for instruction chavo develop or now are one the question paper those and that's the one room and the like paper alien that night. Next time. But that's fine. And I know Janaka top 160. Okay, so let us calculate, guys, the Arin. Let us calculate the value of X. How can we calculate this value of X? How can we calculate this value of X? Share the ideas.
How about the instruction? Okay.
Pellets of mass X are added to sufficient distilled water to prepare a solution of 25 in the flask. In other words, we're adding a certain mass. We have 25 volume. We're adding a mass, a certain X grams to this one, right? So after adding that certain grams, we only what is that? Oh no. About 12 centimeter cube was added. we are adding 12 of what? H2SO4 ne? With concentration of what? 0.1. So after doing this, we found that the pH of the solution is 12.56. The pH of the solution is 12.56. So the first thing that we're going to do here is to calculate what? Is to calculate, we can even calculate the concentration of sodium hydroxide in the solution. We can even calculate the concentration of sodium hydroxide in the solution. So, but let us use a step-by-step method. Let us first calculate the concentration of the solution of H3O plus. So we're going to use pH. No? So what is the pH here? You know, it's 12.56. And from that one, is equals to what is the concentration here? Can you take the 10 to the power negative 12.56?
2.754 times 10 to the exponent negative
10 to the power negative what?
13.
13. Negative 13. Okay. Now we have that concentration. So let us calculate the concentration of OH minus is equals to 1 times 10 to the power negative 14. And concentration of OH minus is equal to you are substituting that 2.754 times 10 to the power negative 3.
Over answer 0.036.
What is the concentration?
0.036 mole per cubic decimeters.
Zero 0.036 mole per decimeter cube, ne? Mole per decimeter cube. So this is what remains after the reaction. Remember, this amount is what remains after the reaction. The concentration that remains after the reaction. So let us calculate the number of moles in excess of this OH minus, right? It's equals to CV. What is our C? 0.036 multiplied by 0.006 0.37.
Mm.
Okay, then what is the answer?
Yeah, times 1.34 times 10 to the exponent -4.
-4 mole. This is the number of moles in excess, ne? This is the number of moles in excess. Okay, how can we calculate the number of moles that reacted?
Wait, what's it? What's it?
Hello?
It's not in
The number of moles of sodium hydroxide in excess.
I don't know what OH minus in the shares now. Okay, but it's fine. You're fine.
Explanatory sodium hydroxide is 1:1 ratio.
Yeah. And
It will-
come back number of moles upon or number of moles of OH minus, but okay, Jeff and I'm going to and expected.
Yeah, it's OH minus hydroxide, ne? The one that this is it. The solution.
What's it?
Okay, now let us calculate the number of moles that reacted. Yebo?
I think Chiparo calculate.
Huh?
Look,
Well, okay. Calculator, yeah.
Erin,
Only 1.3 times 10 exponent -3.
1.3.
let's go round. And come again.
1.3.
Tungo. Mara Jeffan. Aba 1.3 ngor tiro ngwada round a kanju. Ne tungo round a calculate.
Thompson for RR is not power.
Mara ndi power na ndio ne.
Or in the -3.
Kana bandito da bandi 0. Abandido 0.036 times 0.0 ndi 0.0037.
Is it 0? Is it 0.37?
Ndo na -4 14.
It's 0.37.
-4.
Ndi 0.37 usini 0.037.
It's 0.37, yeah.
Nendo kongdo ngwala zwe ngwala.
We are converting
Ndio
this
ndi -3.
37.
So yeah.
Then the answer is what?
1.332 if round times 10 to the exponent -4. -3.
Okay, we're saying
334 332
times 10 -3. So I want us to calculate number of moles of H2SO4 it was added. It's equals to CV. C concentration 0.1 and 0.012. Can I have number of moles here? What is the answer?
0.0012.
0012. What is the number of moles of phosphoric acid? Now let us calculate number of moles of this sodium hydroxide. This is the one that is 2 times, ne?
Mm.
And the answer is
22 eyo kana ndi 2 kane madeni
is 2 times.
Reference ndi 0.0024.
2 times 0.00.
24.
The answer is what? 0.0024. Zero point 0.0024 mole. This is the one that reacted, ne? Okay. Then number of moles that was added. Number of moles is equals to the initial one. The initial number of moles is the one that reacted and the one in excess, ne? Which is 0.0024 plus 1,332 times 10 negative 3, and the answer is
Times 10 to the exponent minus 3. 3.732. Okay, 0.004 sharp.
0.004.
0 ndo zvirounda. Ndiambe zvenda rounda kana.
It's 0.00. I can't do the question around.
It's around 3.732 times 10 to the exponent negative 3, which means 0.003732.
It would be
3.732
times 10
to the exponent negative 3.
Negative 3 more. This was the number of moles that was added in that flask. Therefore, once we have the mole,
Mass
is number of mole multiplied by big M. That
times 23 plus 17.
Negative 3. Molar mass of sodium hydroxide, is it 44 or 40? 23 plus
No,
16
plus
plus
0.15 grams.
Okay.
15.
15.
Number 0.0,
0.15.
Ikoma iva yora pesa. Comma. Yeah.
0.15 grams, ne? 0.15 grams. So that is the mass that was added, ne? Is this question simple?
Okay.
No, it's not.
Okay, abaime what's it? I can never ndito process. The current is process. Okay, so renangori of total volume ya mixture ya formea yari 37 cubic centimeters and its pH is 12.5.
The pH of that is
pH
12, ne?
12.56. So neroana
Then
concentration ya hydronium ions it.
Yeah.
So then gorilla does basic. That means that
That is in
chicha excess in the now uri ndi yone ya base iti. So
Awe.
ngori hafhaḽa ndo wana concentration ya hydronium ions kho ḓo i shumisa uri ndo wane concentration ya OH minus ions ine ya ḓo nthusa uri ndi kone u ḓivha zwa uri naho yo yavha yo sala ndi vhugai,
Yes.
like NaOH yavha yo sala ndi vhugai. So then nda wana uri ndi 1.332 mini mini zwezwiḽa, then ngeno nda ḓa nda calculator number of moles dza mini
It was
dza
acid. That was added.
okay, number of
And
moles
you-
dza acid dzo addwaho
Yes.
of
Then
concentration is
0.1.
ono shumisa uri ndi wane dzedzo dzo reactaho
The one that
dza
reacted.
So ndo kona u wana dzo reactaho nda dovha nda vha na dzo salaho ndi a kona u wana dzi dzavha dzi yone mathomoni initially before the reaction, so nda dzi add nda kona u wana number of moles ai sa koni.
So this is
Does that make sense?
This is the question.
Mm.
But it was not that simple. It was not that simple. But if you understand, or okay, this thing of saying the pH is greater than 7, it assists us a lot. Then we can be able to calculate this. And if pH is greater than 7, it simply means that there are more OH ions than H3O plus. So whatever of OH ions is is in excess. OH is in excess, then meaning that H3O plus is not in excess. In other words, we're saying sulfuric acid is not in excess in this case. What is in excess is sodium hydroxide. So once you know that, and you know what the amount of sulfuric acid that reacted, so it's going to be simple. It's going to be simple. That is 8 marks, the one that you are crying about, guys. This is how you answer this question. You use what you are given, and always what you are given, it will ask. Okay, let us take this one for control. You know that we must have some control, because if we don't, remember this question was written by Elena, and not last year, this year, not during June, just September, last month.
September the last month. September the last month. Ai, tshifhinga tshi khou tshimbila zwone.
Tshi slow.
Tshi khou gidimesa ndi khou amba uri like hovha September zwino. Mangalo tshi yo fhela.
It's October. We are counting down to your exams, guys. Why not more counter down what age in those days? Ndikuchuisa muntu reyo vala buku achitobva apa asawedera. Must wait for your studies. How many days left?
26.
26 days.
I know into 25 ngoro kama zero.
Okay, now let us do this one fast. You know, this one is quick peek, né? Peek, we don't struggle here. So write down the two letters that represent two compounds with a pH less than 7. That is acid, né? Let us identify the acid D. That is what I It's this one.
Uh,
And C.
let's see.
Chain isomer of CH3. Then
1,
what is that?
3 plus 5. 5. The pentane yeyo noni, which means rokodoto the the F.
Chain isomer of pentane. Where ke F, ne?
Yeah, I think so.
Dimethyl, yes. Propane. A substance with a fruity smell, an ester.
Ester. D. Yatenda gondi kana. Yatenda mara D.
D can be an acid or what?
Or an ester.
Okay. Let us move to write down the IUPAC name of compound A. A.
Yes. 1, 2, 3, 4, 5. Oh, 1, 2, 3, 4, 5. 1, 2. Yirikuita so. Rikuita so. Purple.
Asizo.
Makorembe.
2 methyl pent
2
1
in. Yo,
1.
pent 1. 1, 2. Oh, in the 1. Pent 1 in. Hashem.
2 methyl
1, 2.
pent 1
Pent 1.
in. So define homologous series. What is
Good.
homologous series? A series of organic compounds that can be described by the same what? General formula.
A group of organic compounds that can be
A group
described by the same. Whose
of
member differs from the other with the CH2 group.
Or which one member differs from the next by CH2 group? Ne? Okay. Write down the general formula of homologous series to which compound B belongs. B is an alkyne.
H2N.
CN.
The alkyne.
Minus 2.
Oh, and then the term. Actually, one of the alkene. That's the one I read the term.
A straight chain organic compound X. Acid X, ethanol, and catalyst, guys. The thing, Maraman. What is this? This is ester, ne? The molecular mass of compound G is that one. And write down the name of the reaction that produces G. It's esterification. Write down the name of catalyst or formula. H2SO4. The structural formula of organic compound X. X. Its empirical formula is C3H6O. Then that is C6H12O2, ne? You can have anything, any compound, right? If that is the empirical formula, so at least we must have 2.
One, 1, 2,
The
1, 1, 6.
The molecular
Oh,
compound of G is 1, 1, 6, and it's no. Let me check. And
and this
its
one.
empirical formula is C3H6O. So that this is G, ne? It's not X.
G, A.
This is G, it's not X. Therefore, X is going to
What
be
I
what?
put it there?
C4. It must be C forward.
I got a
C4.
structural formula.
Yeah, I just want the molecular formula. H8.
Formula H6, K6, H2, H12, which means I'm got it now 5 minus 5 minus
8,
12,
5.
12 minus 5, 5 is 7.
7, eh? Not 8. It's 7.
Nando khair.
H7.
On the 7.
I just, yeah. H7. O2. So we draw this molecule, guys. We can draw this molecule, man. It's ester. It's going to be what? Butanoic acid, ne? You can draw this molecule.
Yeah, baby. Not to
This is
go,
X.
you will never say.
Chifaro.
And the number check professor in the 78.
Ngenye mwathi kozibona.
And look ababona it G yashunguriro ndi C6H12 and yazwa C yanga ngori iko edana una C mbili ka reactant site ri kuno uko dova rari na C mbili, which means uri ve na C that's 6
Oh,
in
yeah,
total.
8. It's 8. Yeah. Yes, 6, then it's 8. Not 8. 8. Can it be 8?
Aye.
We are saying our molecular formula of G, ne, is C6H12O2.
H2O2. Yeah.
So now we have C2 there, right? Meaning that here we're going to have C4, right? And there we have what? H6, ne?
The H6.
Yeah, it's H6.
Remember to 8.
Okay. This one is going to have 8 because when we add that 8 plus 8 plus 6, what do we get?
12, 14. Hey, that's 14.
It's 14.
8 plus 6.
And on the right, we also have 14, right?
Oh, and there's one.
Then we have what? O2.
Then,
Hey, is this one?
yeah.
We
Makes
draw
sense.
this molecule. Then let us move to this one. Define functional isomer. What is functional isomer?
Organic compounds which have the same molecular formula but different functional groups.
Same molecular formula but different functional groups, ne?
Yeah.
Structure of the functional isomer of compound E. Compound E is pentan 2, 1. Then we're going to have what? Pentanal, right?
3. Hayi. Pentan 3. Hayi. You're functional.
Pentanal.
Psychotabaldehyde. Yeah.
Pentanal, yeah. Pentanal. So guys, I'm sending you a question. Let me go. I want to do something. It's like we're going to be load shedded now. So I will send you a question. Let me vamos now. Oh, electricity